In this example, I'll use the product property of square roots again. The problem says to simplify square root 48. 48 is not a perfect square, and if I took the square root of 48 on my calculator, it would give me a decimal answer, not a whole number. So to simplify a radical that is not a perfect square, I need to see if that number underneath, in this case 48, the number inside my radical, has any perfect square factors. So anytime I'm doing square root problems, I take a minute and I come up with my list of perfect squares. And if you do this every time you start doing these problems, you'll get very quick at making the list. So 2 squared is 4, 3 squared is 9, and I will continue on. And I can go as far as I need to making that list of perfect squares for the problem. So the next thing I do is I take my number that is under the radical, in this case 48, and I just quickly make factor pairs for it. And I can use my calculator to help me make those. 1 times 48, and then I will always see if 2 works, and if it does, I'll write the factor pair with 2, in this case 2 times 24. And then I'll check if 3 is a factor, and I can use my calculator, and sure enough, 3 goes into 48 16 times. 4 goes into 48 12 times. 5 doesn't. 6 times 8 is 48. 7 does not. And once I've gotten my list of factor pairs, I stop and I start comparing to my list of perfect squares. And when I'm doing my comparison, I'm always starting with my largest number in my factor pair list and going down, and if I need to, I can come back up around the other side. So I check 48 is not a perfect square, 24 is not a perfect square, but 16 is. It is a perfect square, and it is the largest perfect square factor of 48. You might notice that 4 is another perfect square factor of 48, but my goal is to find the largest. So I'm going to go back to my problem, and I'm going to take that square root of 48, and I'm going to break it down using this perfect square factor pair. And I'll put the perfect square first, so 16 times 3. 16 times 3 is 48, and 16 is a perfect square. I will break it up using the product property, and then I will be able to evaluate the square root of 16 is 4. I still have my root 3. There was nothing I could do to simplify that, so my final answer is 4 root 3. I want to show you that if you don't take the time to find the largest perfect square factor, you can still do the problem, but it will be more work. For example, if I took square root of 48 and instead of using the 16, I grabbed this 4, I could break it up into the square root of 4 times 12, which is root 4 times root 12. Square root of 4 is 2, so I would get 2 root 12. The problem is this can be simplified further because 12 has a perfect square factor. 12 is divisible by 12. So I could keep going and make that 2 times the square root of 4 times 3, 2 times root 4, root 3, 2 times square root of 4 is 2, root 3, and finally I would get 4 root 3. So I would get the same answer, but it is definitely more work to do it that way. So I'm always trying to find the largest perfect square factor.